Welcome to our very first forces problem. So what I've done is I have the problem that we're going to do over here, and I left the strategy on kind of this right side so we can kind of reference this throughout the problems, and you have this sort of big picture overview of what our strategy is going to be for all these forces problems. Okay, so let's get right into it. So in this problem we have a box, and the box is resting on this hill. And this hill has a 30-degree slope. So you have a box on a 30-degree slope, and it's gonna, I said it's resting, but I take that back. It's gonna accelerate down this hill. So it might start at rest, but it's gonna accelerate down this 30-degree hill. And when it's accelerating down this hill, that hill has some friction, which is told by mu equals 0.1. So remember, mu is your coefficient of friction. So this problem is telling you that there is friction with a mu of 0.1. And you know your box has a mass of 10 kilograms. So what is the acceleration of this box? So that seems like a lot. So let's kind of follow this strategy and see if we can make sense of this problem. So the first step is to draw all the forces acting on your box. So let's do exactly that. So here's my box. Well, how about we keep the same color? So we have, here's my box. Oops, sorry about that. Here is my box. All right, cool. Now, what are the different forces? So, like I said in the last video, that there's basically four main forces we have to worry about. So what I like to do is I kind of just keep a checklist in my head, and I go one by one and make sure I covered all my bases. So the first one I check is gravity. Is gravity acting on the object? And the answer is yes. Gravity acts on everything. And gravity always pushes straight down. So even though you're on this 30-degree slope, you might think, oh, is gravity kind of pushing like this? And the answer is no. Gravity always pushes straight down. So let me draw my line straight then, so that I'm not a hypocrite. So there, okay, let's see, one more time. Oh, it's harder than it looks. All right, so hopefully that gets the point across, that gravity is going to act straight down regardless if you're on your side, if you're on your back, doesn't matter. So always remember that gravity is going to go straight down like that. Now the next force is to check is the normal force, which is any force when you're in contact with something, which we are here, we're in contact with this ground. So if gravity is going to push like this, the normal force is going to always push perpendicular to the surface you're on. So since we're on this 30-degree kind of slope like this, the normal force is going to push perpendicular to the surface. So you just want to go to your surface and go straight up like so. Okay? So gravity is not like that, right? Gravity just goes straight down, but normal force is always perpendicular to the surface. All right. Next force is friction. So friction is always opposite to your direction of motion. So if you are moving down this hill like so, friction is directly opposite of that. So friction is going to go like this. Okay? So we're accelerating down this hill, so friction is going to be going like this, kind of up the hill. The last thing we want to check is tension. There are no strings attached on this object, so there's no tension. All right, so that's cool. We've already done step one. We've drawn all our forces. Now the next step is any force that is two-dimensional, you want to break into x and y. So what are my two-dimensional forces in this problem? Well, gravity is entirely in the y direction, right? So it's going straight down in the y direction, so that's pretty good. But the normal force is kind of shooting off at this angle, and so is the friction force, right? So you might be thinking, let's just break up the friction into its x and y component. So that's like that, and then you have your normal force. We break into x and y. And you would not be wrong at all. This totally works. You can take these two-dimensional forces and split it into its x and y components. In fact, that's probably what I would do if I was first doing a physics problem. I'd be like, these are two-dimensional, and let's just kind of do that. The problem is, though, well, not the problem. Well, yeah, I guess it's a problem. The problem is that, you know, there's two forces that are two-dimensional, which means we have to break both of them up, and that's just a lot of work, right? There's an easier way to actually do this. An easier way is, instead of saying that these two forces are two-dimensional, what we'll do is we'll rotate our x and y axis. So that seems like a bizarre concept right now, I'm sure. So what do I mean by rotate my axis? Well, normally, right, we kind of just assume that this is your x-axis. Anything going left and right is on the x-axis, and anything going up and down is your y-axis. That's kind of just what we assume because it makes sense. But you don't actually have to follow this convention if you don't want to, because right, this is just sort of this arbitrary convention that we made up in society, because in general most things in life go left and right and up and down. So we've kind of said, hey, this is a nice convenient way of doing things. But what we can do is you don't have to follow this. In fact, you can rotate your axis. So you can say, I'm going to say, well, let's get rid of this now. I'm going to say that actually this is my x-axis going along with this hill. This is my x, and then this is my y-axis. So I've kind of like taken this and I kind of rotated a little. So now this is your x-axis and this is your y-axis. And when you do that, right, if this is your x and this is your y, right, this whole thing is your x-axis and this is your y-axis, then all of a sudden your friction force and your normal force are no longer two-dimensional forces, because actually now if you look at it by this point of view, your friction force is along the x-axis and your normal force is along the y-axis. So now what's two-dimensional? Well, now gravity is two-dimensional, right? Because originally it was going down, so we kind of just assumed it was one-dimensional. But if you look at it from this axis over here, gravity actually it's not entirely in the y or x direction, it's kind of going at an angle. So we can now split gravity into y and x. So here's your y and here is your x. Okay, so whenever we do this, there's usually two questions that come up. The first is, whoa, can we just do that? We can just rotate our axes like this? And the answer is yes, okay? Because I kind of alluded to this. If this is just an arbitrary convention, but you can rotate it any way you want. The second question is, why do this, right? And the reason for doing this is because now I only have to split up one of these forces into x and y, so that's less work for me. Whereas before, I had to split up two of these forces into x and y, which is a little bit more work. And when I was first learning this in class, I used to think, you know what, is it really that much more work that I'm going to have to rotate my axes and do all this confusing stuff? So I kind of rebelled against this concept. I was like, I'm not going to rotate my axis. I'm just going to do it the good old-fashioned way. And you can actually get away with that for a little bit, right? Because it's really not that much more work to split up two forces. But the problem is when you start doing more complicated problems, you're not going to just have two forces. You're going to have a lot more forces. You're going to have maybe 3 or 4 or even 5 forces. So then that's where this really comes in handy. Okay, so right now it may seem like you're not really saving yourself that much time, but practice it now because later on it's really going to come in handy. So we're gonna do it like this because I want to get you in that habit. Okay, sweet. So we've split up our two-dimensional force, which is weirdly this force of gravity, into its y component and its x component. The next step is to add up all the forces. Let me draw it here. So add up all the forces in x and add up all the forces in the y direction. So what are the forces in the x direction? Well, now remember, x is along this hill, right? So x, what is an x force? Well, now friction is an x force. So we have friction is going along the x-axis. So that's a force in the x direction. What else? Well, you have the x component. Oh, and friction is going to the right, right? If we look at the right of with this new axis, it's going along the right on this x-axis. So anything going to the right is a positive thing in physics. So this we keep as positive. Cool. Your force. So what's another force in the x direction? This right here, right? The x component of the force of gravity is also a force pushing along the x-axis, and it's going to the left. So I'm going to say we also have a force due to gravity, comma, x, All right, force due to gravity, comma, x, and it's going to the left. So you might be tempted to just kind of put that negative sign in there. And you could do that, but I'm going to show you kind of a different way. So it's going to the left, but I'm gonna keep it as a positive value for now. But as a mental note, I'm going to remember that this needs to be negative eventually. And we'll get to this back in a sec, okay? So hold on for a second. But we know it should be negative because it's going to the left. So this will be negative eventually. I'm just leaving it as positive for now, and I'll show you why in a second. So anyways, you have a friction force in the x direction. You have an FGX in the x direction. And that's going to equal, that's it, right? You have no more forces in the x direction because you have normal forces left, which is going along the y. And you have the y component of Fg, which is also along the y. So you're done. You've added up all your forces in the x direction. So what does that equal, right? Because step 4 is, what is the overall net force? Well, someone's pulling me to the right and someone's pulling me to the left. So what is the overall net force? Well, it's somewhere in the middle, right? You're not going entirely along the right. You're not going entirely along the left. You're somewhere in the middle. But so whenever you have to figure out your overall net force, just ask yourself this question. Are you moving or are you not moving in the x direction? So are we moving or are we not moving? And we are moving, right? In the x direction, we're going down this hill. So since we are moving, we do have a net force. And that net, so I could write this equals, yes, we do have a net force. But what is a force? A force is anything that has a mass and it accelerates, right? So we can just go straight to that step. We can say this is mass times acceleration. So, whoops. So we have someone pulling to the right, someone pulling to the left, which will make negative soon. And you do have this overall net force, which is going to have this overall, so maybe I should write net acceleration, a net, right? Because that's your overall net acceleration is there. All right. Let's do the y forces. So what are my forces in the y direction? Well, we have the normal forces kind of pushing up along the y-axis. So you have normal force. You have the y component of force due to gravity pushing down. Okay? Force, gravity, also along the y-axis. And since it's going down, I also expect this to be a negative number. Okay? But I'm not going to make it negative right now, and I'll show you why in a second. But I'm going to make a little mental note in my head that this should be a negative number. Okay? That's it. You have something pushing up and something pushing down. You don't have any other forces in the y direction. So what is the overall net force in the y direction? So we have to ask ourselves, are we moving or are we not moving in the y direction? And in the y direction, we're not actually moving, right? Because we are moving along the x-axis, but along the y-axis, we're always at the same y level because we're always on the ground, right? We're not flying off the incline. We're not sinking into the incline. We're not moving along the y-axis. So because we're not moving, we would say the net force in the y direction is 0. Okay, so something's pushing up, something's pushing down, but we're not actually moving along this y-axis. If we were, the object would be flying off the incline or sinking into it, and we're just staying on the ground level, right? Which is it's a ground level of 0. So we're only moving along the x-axis. All right, so look at that. We've drawn our forces, we've split 2D, we've added up forces in the x and y, and we've determined our overall net forces. So now, once you've done these, now you have permission to just plug in all your numbers and solve for whatever you need to solve. So this is sort of the hardest part of every physics problems. Once you reach this stage, you are good to go. So let's start plugging in some numbers. So let's start with this force of gravity so we can clarify this confusion going on. So what is your FGX and FGY? So let me complete this for a second. So we said that we are on a 30-degree incline. Okay? So if we're on a 30-degree incline, then this angle right here is also 30 degrees. Why is that, you ask? Well, let's see. If this is 30 and this is 90, then therefore this right here is 60. And since this is 60, the remaining has to be 30. So you can use this trick every time. So and you actually have to. So they're going to give you the angle of the slope, but you're going to use that as the angle right here when you split your force due to gravity into its x and y components. So this angle here is always equal to this angle here. So that's nice. Okay? Now that we know this angle and we know this is a right angle here because x and y are always perpendicular to each other. So we can write some sine and cosine equations for what's going on in this triangle. So we can say, look, the sine of that angle, of this 30-degree angle right here, what is sine? Sine is opposite over the hypotenuse. So what's the opposite? It's this x component, right? The fg comma x. So sine equals opposite, which is fg x, divided by the hypotenuse, which is just your force due to gravity, this blue arrow right here. So sine is opposite over hypotenuse. Therefore, what do we need to solve? We need fg comma x. So therefore, fg comma x equals fg sine of 30. Right? I just multiplied this over here. All right. And last but not least, what is Fg? Okay, so we haven't talked about this yet, but the force due to gravity on an object is going to be what? Well, a force is just mass times acceleration, right? So if we're talking about the force due to gravity, it's going to be the mass of that object times the acceleration caused by gravity. And we already saw this in kinematics. What is the acceleration due to gravity on an object? It is negative 9.8, right? Because it's always down, so it's negative, and 9.8 is just this constant that has been figured out. So really, what is force due to gravity? It's the mass of the object, which is what? 10 kilograms. 10 times the acceleration due to gravity, which is negative 9.8 times sine of 30. That is your Fg comma x. So let's put that in here. Okay, so we figured out that it is 10 times 9.8 times negative 9.8. So I'm going to just say that's negative 98 sine of 30. That is your FGX. It's negative 98 sine of 30. And notice it's negative, right? It's negative. And that makes sense that it's negative because it is going to the left. So that's why I did not make it negative up here. Because if I made it negative up here, that negative would cancel with this negative, and that would make it a positive value, and we would be adding to our overall forces and be getting a much greater net force. So this is tough because you're tempted to make it negative, but you have to just remember that when you solve this, right, the reason it comes out negative by default is because that acceleration due to gravity is negative 9.8. So when you are solving FGX and FGY, you want to write them down as positive initially, but then make a mental note in your head that, oh, this actually has to be negative. If it is, right? If it is going to the left, then make a mental note that this needs to turn out, eventually this needs to turn out as a negative quantity, okay? Some professors will actually go ahead and make this negative here, okay? They will subtract it, but then when they are doing this over here, they're going to write positive 9.8, and then that'll give you an overall negative quantity. You can do it that way as well. I just have this habit of always writing negative 9.8. I don't like the confusion. I always like to think gravity is negative 9.8. So I like to just always keep one rule as negative 9.8, this gives me a negative number, and that makes sense that this overall quantity is negative. So as long as you're, at the end of the day, you are getting a negative value for your FGX, then you are in good shape. And you should expect a negative value because it's going to the left. So hopefully that's not as confusing. And if it is, just kind of rewind this video and kind of listen to it a couple of times. And hopefully in the future we'll also clarify it. Okay? So let's keep going. So we have that. So that's nice. This equals, the mass is 10. So let's start plugging in other numbers. Acceleration, we don't know. That's what we're trying to figure out, right? The acceleration. Okay. And force of friction. What is force of friction? Well, actually, let's come back to this. So let's go down here. Let's finish this force of gravity. So we got the sine. Let's do cosine. So cosine of 30. So yeah, let's finish force of gravity. That's good. So cosine of 30 is adjacent, which is the y component, FGY over the hypotenuse, which is FG. So cosine is adjacent over hypotenuse, so you have FGY over FG. So if I multiply this here, FGY is equal to FG cosine 30. So FGY is equal to FG cosine 30. And then what is FG? It's just your mass times negative 9.8, right? FG is just mass times acceleration, and we know our acceleration is negative 9.8. So really, I'm going to write this down here. So FG is your mass, which is 10 times negative 9.8 times cosine of 30. That is FG. FGY is FG, which is mass times negative 9.8 times your cosine of 30. That is your FG in the Y. I don't want to make it too messy. And look again, we expect a negative value, which is what we got. Okay? So always be a little bit paranoid about your signs. When you generate a value, think, does it make sense? Does it make sense that this is negative? Yes, because it's going to the left, and we need this to be a negative value. Does this make sense that this is negative? Yes, because we're going down, and down means negative, so therefore this needs to be a negative value. Okay? And let's plug in the rest. So do we know normal force? We don't. So there's actually no formula for normal force and tension. There are formulas for this and this. Okay, we already touched what is force of gravity. That's just mass times acceleration due to gravity. So that's the formula for this. And then friction we'll get to there in a second. So let's keep going. So you have normal force plus all this stuff equals 0. So if you plug all this into a calculator, you can actually solve for normal force. You can say normal force equals, let me look that up 1 second. So what is my normal force? If you plug all this into a calculator, you will get that your normal force is 84.9 newtons. Okay? And anytime you generate a value, think, does the sign make sense? So does it make sense that this is a positive number? Well, yes, right? It's going up along the y-axis, and that this should be positive. So it makes sense we got a positive number. If you got a negative number, then you know you did something wrong. So that's one of the cool things with physics. You can actually really you can kind of double check your work and have a good idea if it makes sense, if you're right or wrong. Obviously, do I know if the 84.9 magnitude, if that's correct? That you can't really know, right? Unless you keep plugging into your calculator and making sure. But you can definitely check the sign, and you should definitely do that all the time. Okay, now let's go back. So what is force of friction? Well, friction, remember, the formula for force of friction is mu times the normal force. So anytime you need to solve friction, you need to get the normal force first. That's why I went down here and I did all this stuff first, and then I'm going to come back up. So you don't have to start with x and y. I mean, what am I saying? I'm saying is, actually, it's in your favor to start with the y stuff first and then come do the x stuff later, okay? And that's something people don't really tell you, because intuitively we just usually, I don't know why, we generally want to do x first and then y first, maybe because x comes before y. But I'm telling you now, it makes more sense to do y first and then x, because friction involves the normal force, which is a y quantity. So if you solve that, now you can say, what is mu? Well, mu is 0.1. And what's your normal force? Is 84.9. So we have friction, we have our FGX as a negative quantity, and does it make sense that friction is positive? I'm going to be very paranoid about this. So does it make sense? Yes, it does, because friction is going to the right. So cool, we have positive, negative, equals 10a. If we plug all this into our calculators, okay, we will get our answer. And before I even give you the answer, again, do we expect a positive value or a negative value for acceleration? Well, it's accelerating down this hill, which is to the left on our x-axis. So we actually expect a negative value, and we do get that. We get negative 4.51 meters per second squared. So isn't that cool? So we have just done our very first problem on forces, and I covered a lot, so hopefully this wasn't too overwhelming and it was actually useful and helpful.